Thanks.
Hey guys, welcome to today's session. This is session number 4 in the series of total 5 session. This is session number 4. And today Abhishek is going to discuss more into data analysis, more into exploratory data analysis and predictive analytics. So let's start with a recap. Abhishek, over to you.
Yeah, good afternoon, everyone. Good morning, everyone. So this week we will focus on our predictive analytics. So we'll use one of the predictive analytics algorithm, linear regression, and we'll take a look how it is being used in data science. And like what we did last week, we had to do a little bit of exploratory data analysis also. We'll use different data set this week because WHO data, like as I said, totally depends on data set and what you would like to plot out of that data. So we'll use different data set to plot some of the graphs. We'll dive into the model building process, and we'll take linear regression and multi-linear regression as one of the example. And then we'll look at like what are the parameters using which you can decide the model evaluation or model efficiency. And then we'll open the floor for Q&A. So in our exploratory data analysis, some of the graphs which are important here is distribution plot, box plot, scatter plot is really important when you are going to do the linear regression. Histogram, line plot is also important when you are looking for trendings, and the pair plot. So we'll start with few of the exploratory data analysis. So let me share my screen again, and then because I have to share another application. So give me 1 second. All right. So you should be seeing my Jupyter notebook. I'm clicking on new and we'll select Python 3. So session 4. Okay. So as I said, we had a few exploratory data analysis. We looked into the, I guess we looked into scatter plot. We looked into the bar plot last week. So this week we will look at some of the other plots. I am not getting into too much of the plotting because exploration is, I mean, as I said, it's really important, but I have given you a few links which you can use and you can explore what type of graph you need and at what occasion, because it totally depends on what kind of data you're going to present to the executive. And when you work in the companies, it's really important to choose right graph at the time when you going to show the data to the executive. So keep that in mind. So let's start with some of the basic things. So what I'm going to do, I'm going to, as usual, the first line I'm going to do is import a data set in our Jupyter notebook. So what I'm going to just use simply NumPy. And then I will use import pandas. Also, remember we used a few of the libraries for our exploration. We'll use some of those libraries. So for exploration, we use matplotlib and Seaborn. We'll import those two libraries as well. And we'll show that we'll use the matplotlib inline to show the results in line with the matplotlib after the execution. So these are the very simple 5-line I'm using. I use the same 5-line in our last example as well. Now for today, what kind of data I'm going to use is going to be a little different. Last week, we used COVID data for data exploration. For this week, we will use the e-commerce data. The e-commerce data will talk about like the customer ID, address, how much time customer has spent time on the website, how much time customer has spent time on the app, and like for how long customer is our premium member. So these are like important data which you get when you work for a companies like Home Depot, or let's take an example of a company like Walmart, who has mobile app and the website both, and they want to know like what is the most important parameter or the metric which affect the sale of my, like, sale on the site, like the amount which customers spend every year or every month or every week. So they have to understand that behavior. They are not looking to predict, like, okay, what could be my average future sale. But for to answer both question here, we will use the same linear regression, but the way you answer that question will be different. Okay. So I'm going to explain you how we answer these questions, like what would be my future sale and what are the different parameters which affect my future sale, so that you can tweak those parameters to increase your future sale more realistically rather than coming from the model, right? So that's the goal of the exercise today, and we will look at the data. I'm going to share this data with you. Uh, any of you would like to work together with me? If yes, then let me ping the data set so that you are not too behind from me. So give me 1 second. I'll put the data set link on the chat so that you can work. Okay, give me 1 second. Okay, so this is the data set I'm using. Use this data set if you would like to work with me. And then let me go back and share my screen again. Okay, so I'm just sharing this data set. Let me just get this. All right, so now I did simple one-line command to read my data set through Panda. So now my data set is here. How would I get to know? I will just do a quick head, which will tell me the first five line of the data frame. What it gives: email ID, address, avatar, and then session length, time on the app, and other related. So as you see here, most of the variables here on the right hand sides are basically numeric, or I would say integer related, right? So whenever we focus on linear regression, we focus on the data type, which is like more of like a float, integer, or I would say the numeric number related data. So we cannot predict, like using linear regression, we cannot predict something like categorical, like whether I will be buying the product or not. That is, we'll use different algorithm basically for that. But something you would like to predict on, like how much money I'm going to spend next week if my spend this week is $50. So that, in that case, you will be needing a numerical data set. So this is what it shows, numeric data set. Now you have the data set, you can play around with this. As I said, first thing in the data exploration, make sure that your data is clean. It does not have any null value. It doesn't have any NaN. It doesn't have any skew data. Like suppose if some of the average session length is 0, then what you should be doing, and as I said, you should be taking the average of the complete data set for all the variables, which is 0. So suppose some of the value here of the time on the app is 0, then there you have two options. Either you remove this complete row, or either you give some value in this field. So the most appropriate way is give the value which is average on that column, so that your data looks okay instead of you having less data. Now let's take a quick look on try to find out, like, what is the distribution. We want to know the distribution of the early amount spent in all of the users in this data set. So what we are going to do, we are going to just plot one simple data set. So we'll use Seaborn. Okay. So can someone tell me like how do you basically identify like the row? If you guys can hear me clearly, can someone tell me like what I should write here? Okay, so let's start. I think this should basically give me distribution plot. Okay, so when you plot any graph, you use the library reference from the top, then the plot name which you are drawing. It could be scatter plot, it could be bar plot, it could be hist plot, and it could be like the box plot. If you're doing box plot, so you just write box plot here. And then depending on what kind of graph you are basically drawing, you should be selecting your variables. So suppose you are drawing scatter plot. In that case, you will have a two variable, x and y. This is a distribution plot. So distribution plot, we are trying to understand distribution of the early amount spent in our complete data set. So this is the distribution. So basically what it does, it arrange everything in a increasing order. And it basically plots plot a graph here. So this is the distribution plot for our yearly times amount spent across our data set. Now let's take a look at one more graph. We will look at one graph I mentioned on the slide called pair plot. Pair plot is pretty common when you have a lesser number of variable in your data set. Like I would say like 5 or 6. You can use pair plot, which gives you a quick idea about distribution histogram and scatter plot. But when your data set is huge, when you have like 20 or 30 variables, I do not recommend you to use this. Okay. So to draw a pair plot, you will be passing the complete data frame here. So pair plot takes the complete data frame. Pair plot does not require like one or two variables. So let's run this, see what happens. Okay, so it's still working. Okay. So now see, you see this, it takes every pair of all the variables and draw a graph, and primarily histogram and scatter plot. So how do you interpret this? So let's take one row as in how do we interpret this? So this is the plot of yearly amount spent, and this is my x-axis. Like how the early amount spent is varying over average session length, time on the app, time on the website, and length of the membership. As you see here, few things you will notice. When you look at these scatter plot, you will say that length of the membership looks linear relations. So if we plot a graph of yearly amount spent with the length of membership, this scatter plot shows linear relations. There's also a little bit of linear relationship, but this is not exactly linear relationship. Linear relationship comes around this area, but it has a very much common like uniform distance from the graph. If we plot a graph here, like the straight line here, passing through this center, you will see the distance between above graph and below graph would be pretty much the same. Okay, so this is how you basically interpret the pair plot. It's a very straightforward graph. Similarly, you can plot any other graph. I'm not getting into too much of data exploration because we will focus more on linear regression this week. So let me move to the linear regression. Okay. Any questions so far? Okay, great. So let's talk about building a model. So as I said, building a model is a process. You cannot build a model like just grab a data set and just pass two variables and just build a model. It is a process which you have to follow to build a model, and interpreting the model also you have to do in the process. So first process, we have completed data collection. We discussed how we collect data. We collect data from the web analytics tool. We collect data from CRM tool. We collect data from the customer care support and the offline sales support. We have the data in our system. Now we do data cleaning. Data cleaning requires a lot of things: normalization, scaling, cleaning. These are the very common word which you will hear when you work on data cleaning. And then we focus on splitting the data in the train and test. So when we work on the designing a model, like a statistical model, we've like especially the machine learning model, not the statistical model, we basically split the data into two set: train set and test set. Why do we do that? There is a reason, because whatever you are going to predict, you need to know whether that prediction happens in a right way or not, because you don't have the future data. So when you do not have a future data to predict your model evaluation, how would you predict? So for a time period, suppose we have a data for like 5 years, and we are building a linear regression model. So we will take data for like first 3 year or 4 year to build a model. And then we will take last 1 year data to run the model, as a data of the fifth year will be input of the model for the first 4 year. Why we do that? Basically, because we don't know the efficiency of the model, because we do not have future data. So to understand the evaluation, even understand the efficiency of the data, we break the data into two different parts: training data and test data. Any questions here? And how you choose training data set and test data set, it totally up to you. When you work in the like in the company, you will basically choose 50-50 options also. So 50-50 options is really common. Like you split the data into 50-50%. 60-40 is also common. And as I said, if you have a yearly data, you break it into 3 years or 2 years or 4 years or 1 year. And then when you have this data split, you would like to know, okay, which model I have to use, right? So you choose a model, and then when you choose a model, you have to apply the model on your training data set, which we call it like training the model. We will fit the model into our training data set. And then after we build a model, we have to test the model on the test data set as well. That we call test your model. And then finally, we evaluate your model. So means we try to evaluate the model based on the parameters what we basically get. So we'll discuss on that as well. So building a regression model, linear regression model, sometimes we call it regression model or linear regression model, whatever you can call. So these are like the primary 5-line you will see here. These are very common 5-line code in the linear regression model. I'm going to explain all these 5 lines, what we are doing here. First line, what we are doing, we are creating a variable called x. Okay. In this x, what we are passing the variable, different variables. So here's the difference between multi-linear regression and then single linear regression model. So here in this x is my input variable. Y is my output variable. We want to know my customer's early amount spent based on these variables. Okay. So this one we call output variable. These are like input variable. Okay. Now in this model, if you select one variable, like suppose we select average session length, then it becomes single linear model, linear regression model. If we select multiple variables here, then my model becomes multi-linear regression model. Okay. And how we choose that, how do we decide whether we should be using single linear regression model or multi-linear regression model? So it depends on the requirement, of course. Like you would like to understand linearity between two variables, then you will use single linear regression model. And suppose you would like to understand the linearity of your data with the help of multiple variables, then you will use multilinear regression model. So here, just to give you an idea here, this y will predict the value based on these variables. Any question here, like what we are trying to do in the first or second line? It is taking the value from the data frame df, which we have just created, and storing into the x. And similarly, it is taking the value from the data frame from this column and storing into the y. Any question here? Okay, good. Now, here in this case, third line. Third line is using our inbuilt function in Python, which is train test split. Train test split is a function basically which splits our data set, the complete data set, into x and y. Sorry, it's complete. It's basically split our data set into test and train, and we pass the x and y value here. So these are the different input parameters. So let's look at the input parameter. X is our input variable, y is our output variable. Test size is one of the parameter, and we have kept the test size equal to 0.4. That means when we say 0.4, it means 40%. So whatever the complete data set, suppose data set has 100 row, it will give 40 rows in the test data set and 60 rows in the train data set. So suppose this 0.4 means 40% data will go into test data set. So that's why we have written test underscore size. It's equal to 0.4. Random state. So we would like to randomly take the data. We will randomly take the data. Random state is equal to 0, 1, 0, 1. So when you do not assign random state is equal to anything, or suppose you leave this, what would happen here is that whenever the split will happen, you will get a different split all the time. So you assign a random state is equal to 101. That means whenever you run this line, you will get the exact same sample. When I'm going to show you, like when I'm going to change 1 or 2, then you will see I will be getting different split. I mean, the split will be 60-40, but the data which will be there in the split will be different. That is why we assign one constant random state to get the same similar data set all the time. And then you are creating an object for your linear regression, LM. And then here in this line number 5, we are fitting the LM with these two variables, train variables. So as I said, you always build the model on the train data set, and you evaluate your model on your test data set. This is a very common line you will hear from everybody in future if you are going to learn the data science. Right? Any question here?
Yes, I have a question.
Sure.
Yeah. Does the random states 101 always mean that the sample will always be constant at 101?
So this is like a kind of like you can change 102, 103, but as I said, like suppose I'm running here, I can choose it as like 20, I can choose it 30. Okay, you can change as per your need, but this is just like a kind of a starting point sort of thing. While you run this command again and again, you shouldn't be changing to 20 to 30. You always keep it 20 so that you will get the exact similar data set.
Okay, thank you.
You can change it as many times you want.
Okay.
Any question?
So one thing on the random set is that 101 something kind of a seed value, like no, to generate random numbers we give seed value, right? Is that something like this?
It's sort of a seed value. Yes, you're right.
Thank you.
Any question? I will wait for 1 or 2 minutes because these are like the 5 important line which I'm going to work now. Hope you guys have worked on some of these aspects, but okay, let's focus on 2 or 3 more things. So before we build this linear regression, as I said, a linear regression like pretty much the same for multi and single. You just have to pass the different variables in X. Now, when we pass different values in X, we have to make sure that the value, like the relation between this guy and this variable shouldn't be very tight, you know. So multi-collinearity is a very common problem in multi-regression model. So where you'll have a two input, this one and this one. These two inputs are highly dependent on each other. So when you have that kind of input variable, then it becomes problem in your model. So before you build a multilinear regression and before you choose the value of these variables, input parameters, like which input parameter I should be using in this X, before you do that, you basically try to understand the correlation between these two variables. So you run the correlation function on these two. And then if the correlation is like not very strong, then you will see that we can use it. So, but when the correlation is very high, that means you cannot use these two variables together. Otherwise, your model performance will be not that great. Okay, that is really important. You should remember. So how do we check the correlation? So before you build the multilinear regression model, check the correlation of all the variables. So there are inbuilt libraries using which you can check the correlation across all the variables. And that will give you an idea whether which variable you should be using in your X, which variable you shouldn't be avoiding. You know, you can still use one of these variables, right? So you cannot use these two together. You can use this, but if these two are highly correlated, then don't use together. So that is one of the problem with the multi-collinearity and normality in distribution. So linear regression model assumes that the distribution of the input variables are like normally distributed. So when you go and read about how the normal distribution is, where your standard deviations do not fluctuate a lot. So that's how your normal distribution is. So the output also will be like normally distributed. So that's one of the assumptions in linear model. So sometimes when you build the model on a real data set, try to look at your input variables, how the input variables are distributed. Are these input variables are distributed normally or not? And how do we do that? There are so many functions in your pandas. You will have a normal distribution functions. You can draw a graph. You can draw a distribution graph, like distribution the graph which we have created. You know, let me show you that. So this is normal distribution. You know, standard deviation is not changing a lot. So to understand your distribution of your data, you create a distribution plot. Very simple. That's how you will get to know how my input variables are distributed, how my output variables are distributed. Your output variables needs to be also normally distributed. That's one of the assumption on when you use linear regression model. Okay, so any question about distribution? Because you will definitely face these problems when you work on the real data set, because real data set will be huge. Sometimes what happens that some of your data set are not normally distributed. So how would you convert into normal distributions? You make assumptions, you do the cleanings, you take a portion of the data set which are normal, and then you work on that. There are different steps how to deal with such kind of issues when you work real time. And other thing, the third point to remember when you work on the linear regression model is independency in the values of output variables. So linear regression model gives you output. Okay, that output shouldn't be interrelated to each other. That output should be independent to each other. You know, so that is one of the assumptions and things to remember. There are other models where outputs are correlated to each other, which you will learn in future. Any questions? These are the really important thing when you work on the real data set. Any questions here? Okay, no. So now let's dive into linear regression. Okay, so here is our demo session 4. Okay, cool. So now let's do one thing. So what is the first step we should be doing? Remember the 5 line of the code which I was sharing you? The first line of the code was to create X and Y. Okay, so we will create X first. So let's start with the single linear regression. We'll quickly run through that. And when we will make sure that, let's use this df.info. So it's really important that these are the very real challenge. So you try to copy, name of the variables would be huge. So you just use .info and you just copy paste the variable name here instead of typing it. So these are the best practices you should be doing. Okay. So let's capture the value of a time on the app. Let's see. Time on the app is in my X, and my predictor should be this guy. Okay. So we have decided that we will start with the single linear regression model, and then we will move to the multi-regression model. So let's just do a quick run. Okay, it works fine. So my third line, let's just use the third line, and we'll use the third line exactly what I've written on the slide. You don't have to change anything. Okay. And I will show how the random state is going to affect our training data set and test data set. Okay. Now let's see, I have taken random state as 100. Okay. Now we run this. Okay. So we have to use the library here. So to run this library, okay, I think I will use the library here. Run this library top. So, okay, so just to give you one of the key concept here is, so there is another library called sklearn library. Sklearn library in Python handles all of the machine learning algorithms. So sklearn is really important. So most of the variables related to, like most of the functions related to machine learning will be available in sklearn library. So you should be using sklearn library very often. And that's where I'm trying to import this function from this library. So I run that, and then I'll run this. Okay. Okay. So looks like I'm using small n. So yeah, these are the real-time issues which you will have. Okay. Now we have the data set. Now let's see what is my x underscore train. Okay. X underscore train is having these two values. Okay. Now let's just change this value to 3. Okay. Let's run this. Okay. And I will leave this and I will run this here and see what would be the value of X train. See, the value changes, correct? So when we change this back to 100, let's see what happens. See, exactly the same. So as you said, it's kind of a seed value where you want to make sure that your sampling, like the distribution between test and train, is going to not change. So that's why you use random state. So now let's move on to building our model. So we will also import our linear regression function from sklearn. So we'll import this linear regression. Now let's create an object. Our object will be lm is equal to, let's go and use the same code here, what I have mentioned. Let me copy both actually. Okay. So as I said, I'm creating an object and I'm fitting this. I'm calling this method in this object using my trained data set. Let's see what happens. Okay. Let's go back and run this first and dot fit. Okay. Expect activity. Give me 1 second. Handle this. Okay. Give me 1 second. Let me handle this. These are the real problems you will have when you work with the linear regression. Okay, no worries. All right, so let me go back and change it to different things.
So while Abhishek is doing troubleshooting, so guys, these are the kind of problems you will always face. So theoretically, everything looks good, but when you actually do it, there will be problems, and these problems also give us an opportunity to learn. And with this troubleshooting, you will learn a lot of things. But I hope by this time, you guys know what exactly is happening here, what Abhishek is trying to do, and how he is proceeding to the exact end goal step by step. I hope you are clear. I'm not expecting you will be able to write these codes immediately, but I think you are getting the point what Abhishek is trying to do.
Okay, so let's start from the top. Let's start from the top. Let me run the data set from the top. I think I missed one or two things. Yeah, so what happens sometimes when you try to get your X variable and Y variable, the shape of the variable, like it might not be like as you expect, like whatever value you try to extract from the data set. It could be like, uh, so this fit function, it takes value in array, like the 2D array. And I think what error we were getting is we got one dimension array. So it was basically asking for 2D array, but we were passing 1D array. So that was one of the very common error which you will see. So how to resolve this one? So let me try to do that. Okay. Okay. So let me go back and share my screen. I was able to get this error now removed. So no issues with that now. So let me just do that. Okay. Can you see my screen again?
Oh, yes, we can.
Okay. So what we did, this is for the linear regression. We were working on time on app. So we'll use this linear regression. And I have also have a like another variable, which is for the multilinear regression. Okay. So let's run this. Okay. We were here and we will perform the uh, fit function on the linear regression object. Okay. And we get this. And then what we're trying to do, we're trying to look at the intercept of the linear regression model. One thing, as I mentioned to you, what is linear regression? Linear regression is basically going to give you the prediction of y in the format of y is equal to mx plus a. Mx is going to be your like x is going to be your input variable, and m is going to be your coefficient. And um, sorry, m is going to be your intercept, and a, whatever will be there, will be your intercept. So we everybody knows about how linear regression works, like linear equation works. Y is equal to, just say mx plus c, mx plus c. Usually this is common. So y is your output variable, m is your coefficient, X is your input variable, and this is your intercept. Oops, sorry. Yeah, this is right. So as you see, there are two things which you can print or you can get. This, when you run this, it gives you two things: your intercept and your coefficient. And when you are running single linear model, it gives your coefficient, like it will have only one coefficient. But when you are going to run the model on multi-regression variable, it will give you coefficient for all the different variables. Okay, so now we have our intercept and we have our coefficient. So this is our coefficient, which is array, which is 40. Now let me remove this. Now, what we are going to do, we are going to predict the value. We are going to predict the value of the early amount spent based on time on the app. And we are using this variable predictions is equal to LM is our function, our object, linear regression object. And then on top of it, we are basically using this function predict. And what we are passing, predict function takes one variable as input, which is your X. X is going to be the input variable. Okay. And this plot, basically, it's about plotting your Y from the test and all the predicted variables. So remember line 43, what it does? We are using the test data set to predict the value of our model, because we already know the value for the last 400 customers or 40 customers, whatever we are using. So we know the value of the yearly amount spent, but we are using this model to predict the value. And this line is going to basically create a plot, scatter plot, with the Y value, which is already there in the test data set, and the predicted value in the what we are predicting here using the model. So this plot is nothing but it is giving us an idea about how the distribution of my predicted value and how the distribution of my already existing value of Y from the test data set. So as you see, predicted value drawn over here and the test value is drawn over here. So some of the values which is on the test, like our predicted values has here around here. So I would say I can make this graph better, because I need to know which point is for the test, which point is for prediction. So you can update those values here. All those things you can do in the scatter plot. Now let's talk about some of the important things of the model, like how can we predict the evaluation of the model? Like, how do we know that this model is good? Now we got the prediction here. Now we know that this is the values which model has predicted. Now we want to know like whether this model is good or bad. That's one thing, it's always in our mind. So now let's take a quick thing about model evaluation parameter. So when you create a model or when you predict some values in using your model, you will see some very commonly that some of the values of the predicted values, like I'm talking about predicted values, some of the predicted values will be either higher than the actual value or either lower than the actual value. Okay. So there is a term which basically we use in data science called residual. Residual is basically difference between the predicted value and the actual value. It could be negative, it could be positive. And based on the residual, we basically calculate different things to evaluate our models. One of the most common thing which we will calculate using residual is root mean square error and mean absolute error. Okay. And there is another parameter called R squared. R squared is what it is. It's basically a percentage of variation in the dependent variable explained by the predictor. Like predictor means the value which we are the variables which you are using to predict the value. So R square, when you try to understand the efficiency of the linear model, focus on two things. My suggestion: one, R squared value, and the second, root mean square value, which is very common, RMSE. This is a lot of people say RMSE value of the model. R square and RMSE is a really common parameter to evaluate any model, basically. So, and what is RMSE? RMSE is nothing but the average of, like, square root, average of the square difference between observed and the actual. Okay. So as I said, residual. So you calculate the residual value. Like, suppose the predicted value is 50, but the actual value from the test data set is 30. So the difference here is 20, right? So basically we do a square of the 20, and then we do square of all the values, and then we take an average of it and then do a square root. Okay. So that's very common. You will have a function which will tell you the value of RMSE of your model, which is really great, no hassle. And lower the value of the RMSE, better. Higher the value of R squared, your model is better. So those are really important things. Now, after building the model, it's really important to understand, like, how can you interpret this model? Your management team is not going to look at your model, like what you're doing. Your management team will ask questions on, tell me how we can improve things using the value which you're getting out of the model. So now let's take a look at a few things. So we have as I said, there are three things important to evaluate the parameters. So this is the value for mean absolute error. Okay. So what we have done, we have used this sklearn library, and we have imported this metrics, and metrics has a function called mean underscore absolute underscore error. It's an inbuilt function. Though you can calculate your mean absolute error by yourself, it's a mathematical formula which is already there on internet. Just search on mean absolute error. It's a very statistical formula. So you can calculate the predicted value, difference of predicted values and the test values, pass it into an array, and basically take an average of it, and basically you have to just basically you will be taking the absolute value. You're not going to take the negative value. Suppose, for example, if the predicted value is higher and your test value is lower, you should be always taking the absolute value, and then you can calculate it by yourself using formula instead of using a function. So as I said, so let's just run this and you get this value. Similarly, you have this mean squared error, as I was talking about, like RMSE value. So this is the RMSE, our RMSE, you know. So let's see what is this. So not this is RM, so this is the RMSE actually. So that is a mean squared error. Now the root mean squared error is your RMSE value. So RMSE value is 68. So if I have a two model, if I'm building if I'm building a model and I'm trying to run the model on two different variables, then whichever RMSE is lower, you have that model is better. Okay, so always consider this point when you build the model, RMSE value and the R square value. Any question here about the model evaluation? Or any questions around the predictions?
Yes, I have a question.
Sure.
Do you always have to convert your data frame into an array when you're trying to fit the data sets into the linear regression model?
No, you don't have to convert into array. No, that is not required.
Okay. Okay, I have a second question. Is it possible for you to have like a higher RMSE and a lower RMSE and a higher R square in a particular model, and a lower R square and a higher RMSE on another model? So how do you make a decision based on these two situations?
Yeah, that's right. That's right. So one of the thing here is, let's go back to the slide. That's a very interesting conversation. So if your R square value is very high, okay, and your RMSE value is very low, if it is happening together, then that we call it overfit model. So model is overfitting. So your data is very linear and your model is overfitting. So that means your data is like your past historical data is good and your model is also good. But the problem with the overfitting of the model is that you don't know what can happen in future. So sometimes overfitting might not be a good thing for your data. So that is what you will think about it, that there is no set values on that. Like if my RMSE value is 40 and my R square value is 60, then only we will say this model is great. There is no such values actually exist in data science. So you need to decide the combination of these two, and then you have to evaluate. So for example, let's just take a simple example. If my R square value is 0.9 and my RMSE value is like higher, like when you say higher, it could be like 500, it could be 400, it could be 50, so let's say it is 100, okay, and my R square is 0.9. So when my R square value is 0.9, that means my data, like the model which I'm building, it's highly linear model, and it is overfitting, because 0.9 says that you have a model which is like almost like your test data set is performing almost exactly on your trained data set. Like this is like overfitting. This is what we call it, overfitting. So there are things like overfitting and underfitting of the model. Suppose your R square value is 0.4 and your RMSE value is very off. In that case, you will say that looks uh, like the test data set performance is really bad when we are building a model on trend data set. That means my recent numbers are not great. My recent numbers are not very much linearly trended. So those
Okay.
are the things you can think about when you look at the evaluation of the model. But read about it on several blogs on Medium. You will find that it's up to the data scientist to decide which value to take to understand this is what we have to take to basically deploy the model to the production. But there is no such value actually. You just compare the value to understand the model evaluation.
Okay. Thank you.
All right, any question? Okay, all right, no problem. So let's just take a look at the distribution of our predicted value. So this is the prediction of our distributed value. And this is the prediction, like the distribution of the existing value. So these are the two graphs I'm showing to you. The first graph here is the distribution of the predicted value. And this is second graph, this distribution of the actual value. So as you see, the distribution is not that bad. Distribution is pretty much the same, is what we are seeing here. And as you see from the RMSE value is just 68, which is very low. So we can say that data is pretty much like the test data set is behaving really good when we have built this model on trained data set. And this is the senior regression model. So what you can do, you can use the multiple regression model also by adding few more variables here. But as I said, you need to look at the correlation of those variables, like how those variables are correlated to each other. So to understand the correlation, we have a function. I think the function names is core. Core function basically tells you the correlation between two variables. So let me give you one simple example, like how would you understand the correlation between two variables? Because that's a really important thing. Give me 1 second. Meanwhile, any questions so far on the model evaluation? Because when you will work when you will work on the real-time data set, then explaining the model is going to be the challenge for you to the executive team, because building the model you can do that, but how you are going to interpret that model efficiency is this important. So that's I'm stressing on this one um, based on my experience. So that's why I'm letting you know why this model evaluation is important. Any question? No question?
Yeah, there are no questions on the chat as well.
Okay. So if there are no questions, I have to show you one thing for wrap up. 1 second. So whoever are like interested in modeling, or who anybody has any past experience in linear regression? You can say yes or no. It's fine.
Yes, in some of the courses we've taken at school. I mean, speaking for myself.
Okay. Okay. Gotcha. All right. Any other questions? Meanwhile, I try to run this for you. Any questions are welcomed. Okay. So Ashish, should we? I think we can take this one in our next class. The next session we can take into the next session. But I'm just trying one more last thing here. Last time. Okay, so let me share my screen again. Okay, let's just want to show you guys one more. All right, so can you see my screen? All right, so as I was mentioning, you basically try to understand the correlation between the variables when you're going to work on multilinear regression. So that you can do through this function. This function is in already in the Python. So you basically use your data frame dot corr. So this is a correlation function. You can assign different method. So there are different correlation method which you will learn when you are into data science, like Pearson correlation, and I think there are a few more. So I think by default, I think it's Pearson method of correlation. So there are different correlation methods which you will learn if you are interested in data science. But this is very straightforward. It takes Pearson. You don't have to assign any method. This is just one simple method, no any argument. This is the data frame, and this gives you a very beautiful table which shows. So this is one of your variable, average session length and average session length. How these are correlated? Of course, this is the same two variables. So this is one. Now, when you have a negative correlation, means there is no correlation between this and this. When you have a very strong correlation, like look at this, average session length has a strong correlation between yearly amount spent. It's good. And similarly, time on the app is also strongly correlated with the yearly amount spent. So let's find out a value like length of membership and length of membership looks like not any like, okay. All right. So it looks like most of these variables are not correlated to each other. So for example, if we look at the average session length and look at the length of membership, the correlation is 0.06 only. Okay. If this number is like 0.6, then probably our next step would be not to use this variable and this variable together in the linear regression. Our next step would be to check which variable I should use. We know that we shouldn't be using this variable and this variable. Then our next question would be to ourselves, okay, if we don't use these two variables together, then which variable I should choose, this variable or that variable? So in that case, I'm going to use the predictor, like the output variable, like which variable is more correlated to the output variable. So average session length correlation is 0.355 and length of memberships correlation is 0.809. So looks like length of membership is highly correlated with the yearly amount spent. So in that case, I'll choose this variable, not this variable. Am I clear? How to choose variable when you are doing multi-regression based on the value?
Yeah, I thought you actually meant to choose the one that is not highly correlated with the other variable.
Yeah, so if this variable, average session length and length of membership, if you see the correlation between this and this is very less. So we can use these variable and this variable together.
Okay.
Okay. But in case if this number would be 0.6 instead of 0.06, then we have a problem of choosing which variable we should be using, whether this or this.
Okay.
All right. All right. Okay. So we have this linear regression. It is a very minor change in a linear regression, in the multi-linear regression model. So what I have taken all the variables here, okay, and then we are splitting the value in the same way, same random state. I'm not going to change anything here, and let's see, and look at the intercept has changed, and coefficient also has changed, right? These are the different coefficient because we are using 4 different input variables. That's why it gives me 4 different coefficient, but there is always one intercept. Okay, now here, let's look at how the value it would be. So if we take all these 4 variables, so this is the predictions, predicted was the test graph. Now let's look at the value of absolute error, very less error when we predict. The mean squared error and our square root error is almost 10, which is great. So in this case, single linear regression model is not going to perform better. So to predict the values of the yearly amount spent, you should use multilinear regression model. So this is how you decide between 2 models. There are 2 models. One is single linear regression model. The second one is multilinear regression model. Here we saw the performance of senior linear regression model, which was not great. And we were predicting yearly amount spent based on the time on the app. When we have taken all these 4 variables collectively together, our model is predicting better. That means we should use multi-regression model instead of single linear regression model. That is the thing which I'm trying to express here. Am I clear?
Yes.
Okay, great. Any questions on the coefficient? Any question on the correlation, multi-regression versus single regression? Which one you should be choosing? Why? All right. No
So there
question.
is a question on the chat, why we are using 2D array in the fitting model from Yash.
Sorry, can you repeat the question?
Yeah, the question is why we are using 2D array in the fitting model.
Because that's the input of the linear regression function. So I am not able to understand the question here.
Maybe we got an error, so that's why he is curious, like why not 1D and why 2D? And yes, feel free to add if you or if you want to unmute, you can
So
ask the
I am
question.
not, okay. So I was not using 2D. Model was expecting 2D from me. Okay, model was expecting 2D from me. I was using 1D. That's why the problem. So to basically to change that, you reshape your output like in input variable, like the array which you create. You use the reshape function. So there are different arguments under reshape function which basically you use. So I was trying to use reshape function. So so one of the common, let me give you example like how you. So I'm giving you article on reshape. You use reshape to convert from 2D to 1D or 1D to 2D based on the parameters what you give inside the reshape function. I've forwarded the link like in the chat, and you can see how the reshape function works.
Cool. He says, okay. Yeah, I think his question was answered. Guys, any other question you have, feel free to post that question in the chat, or you can unmute yourself and ask the question.
Okay, I have one more question. Based on your correlation metrics, can you use the correlation plot to tell the variable that you can select, which is highly correlated or not highly correlated? Can you do that with the correlation plot using Seaborn or Matplotlib?
Yeah, you can do that. You can do the correlation plot, of course. Let me get you that. So you can draw correlation plot through a method through functions, whatever there in the Seaborn. I think one of the common method I would say. Let me see. I mean, I have not used lot correlation plot, but I used like correlation table, which gives me really clear answer, like which variable I should be using. Um, you can create a graph from the table
Okay.
that can be a plot using Seaborn.
Okay.
Yeah.
Thank you.
Cool. So I don't see any more questions in the chat. So yeah, good session, Abhishek. Thank you so much for your time.
One small thing.
Mhm.
The lady who has asked the correlation plot is like you can say that scatter plot is also kind of a correlation plot, you know. So when you look at the scatter plot, you will easily identify how the variables are related to me. Is there any correlation between the variables or not? If you look at the scatter plot, if the values are like really scattered here and there, then that means those variables are very unlikely that those are variables are correlated, you know.
Okay.
When you create those scatter plot across the like the pair plot, remember we created pair plot. That pair plot had multiple scatter plots across all the variables. So those were like the correlations between between two variables. Like
Okay.
each variable, it was in a matrix. Let me share my screen again. I will show you what I was talking about. Okay,
Okay.
1 second. So remember we were talking about this pair plot. And initially we decided, we talked about like how these variables are correlated. So you see all the variables are here. These are the metrics. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's basically using the pair plot also you can see how the variables are correlated to each other. If your number of variables are less, if your numbers of variables are like 10 or 15 variables, then you create a table and then you can take a look and you can create a plot out of it. But there are numerous ways to do another visualization for the correlation. You can find it on Google.
Okay, that makes sense. Thank you.
Abhishek, Rakesh here. I just have one question.
Yeah,
Correct me if my understanding is right or wrong. So, what I was thinking is, so when we are looking at the correlation, consider we have x and y. So, if we have a higher correlation, that is x, if x is increasing, y is also going to increase. Let's consider an example. So if this condition is true, then when we are giving it to the model, if x is increasing, model gets to know that y will also get increased. So is that model is going to gain something from this, or it has to be opposite way? If the correlation is less, then we need to add those features to the model so that it can learn better.
no. So model will decide whether the variables are correlated or not. Model will not do anything on top on with the correlation. You have correlation is only used to choose the variables which you're going to use in linear regression model. But if the correlations are very high between two values or two input variables in your multi-regression model, then your model performance will be basically impacted. You can basically I'll show you with the graph next class. We will show you the graph, like if two variables if you are using which are highly correlated, and you can basically predict the value when you create the residual, when you try to find out the residual of the predicted values and the actual values, when you have like a very highly correlated variables in your multi-regression model, you will see how that performs. The difference would be off a lot. I'm not sure if I answered your question. Do you have any more questions?
No, Abhishek, that's fine.
Okay. All right. Any questions here? So I'm going to share the Jupyter notebook file with Ashish, and he will share it to you so that you can execute the program on your side and you can play along with that. And the next class will take any questions on multilinear regression, and we'll talk about some of the association rules, how the association works in machine learning. So we will talk about that, and we'll take some of the questions. But if next week would be our last in the series, but in case you guys would like to reach out to me to learn more on these things and keep on going by yourself, yeah, feel free to reach out to me. Ashish, you can share my email ID with everybody. Happy to answer any questions.
Perfect. Sounds good. So, guys, I will also be sharing last week's file with you, the Jupyter file. So, thank you, Abhishek. Thank you for your time. It was quite a technical session. I expect everyone to practice because unless you practice, I don't think so any one of us will be able to develop skills around the Python. Again, thank you so much, Abhishek, for this lovely session. It was time consuming. It was technical, but still, I know everyone will do good here. We will connect again, guys, next Saturday, 11 a.m. again in the morning. Till that time, have a fantastic day ahead. Take care. Bye bye.
Thank you.
Thanks, everyone. Bye. Have a good day.